This is SpaceTime, Series 24, Episode 95. Coming up on SpaceTime, the odds of Bennu hitting the Earth get worse, countdown to the Europa Clipper mission, and a major failure for India's space program. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that the hazardous Near Earth Asteroid Bennu now has a 1 in 1,750 chance of slamming into the Earth between now and the year 2300. That's a little worse than earlier estimates of a 1 in 2,700 probability. The new predictions are based on a detailed analysis of new orbital tracking data and characteristics of the 492-metre wide space rock obtained by NASA's OSIRIS-REx spacecraft. The new findings, reported in the journal Icarus, significantly reduce uncertainties related to the asteroid's future orbit and improve astronomers' ability to determine the total impact probability, as well as helping to predict the orbits of other asteroids. The program manager for NASA's Near Earth Object Observation Program, Kelly Fast, says the agency's planetary defense mission is to find and monitor asteroids and comets that come near the Earth and pose a threat. This includes undertaking detailed astronomical surveys, collecting data to discover previously unknown objects, and refine orbital models for them. OSIRIS-REx was designed to refine and test these models by helping astronomers better predict where Bennu will be when it makes its closest approach to Earth. In 2135, Bennu will make a close approach to Earth. Now, it won't hit the planet, but it will pass awfully close. And how close it passes will be affected by Earth's gravitational interaction with it. Put simply, the flyby will change Bennu's trajectory and consequently future encounters with Earth. Using NASA's Deep Space Network and state-of-the-art computer models, scientists were able to significantly shrink uncertainties about Bennu's orbit, determining its total impact probability through to the year 2300 to be around 1 in 1,750. They were also able to identify September the 24th, 2182 as the most significant single date, with a 1 in 2,700 probability of an impact. Now, if it were to hit the Earth, the resulting impact would be the equivalent of 1,200 megatons. Currently, Bennu is one of the two most hazardous asteroids in our solar system, along with another asteroid called 1950 DA, a 1.1 kilometre wide mountain-sized space rock. OSIRIS-REx spent more than 2 years in close proximity to Bennu, gathering information about its size, shape, mass and composition, and monitoring its spin and orbital trajectory. The spacecraft also scooped up a sample of rock and dust from the asteroid's surface. It'll be delivering that to Earth on September the 24th, 2023 for further scientific investigation. The precision measurements of Bennu will help astronomers determine how the asteroid's orbit will evolve over time and whether it will pass through a gravitational keyhole during its 2135 close approach. This keyhole is an area in space which would set Bennu onto a path towards a future impact with the Earth if the asteroid were to pass through it at the right time due to the effect of Earth's gravitational pull. But as well as gravity, there are other forces also acting on Bennu, including the Jovian effect, the process by which the asteroid's surface is heated by the sun during the daytime and releases that heat as infrared radiation at night, in the process generating a small but measurable amount of force capable, over time, of deflecting and changing an asteroid's orbital path. OSIRIS-REx determined the Jovian effect on Bennu was the equivalent to an extra mass of only about 3 grapes, consistently acting on the asteroid. Now, it's a tiny amount, sure, but still significant when determining Bennu's future impact chances over the decades and centuries to come. The authors also considered other perturbing forces, such as the gravity of the Sun, the other planets, their moons, and more than 300 other asteroids, as well as the drag caused by interplanetary dust, the pressure of the solar wind, and even Bennu's particle ejection events. In fact, the team even took into account the force that OSIRIS-REx exerted when performing its touch-and-go sample collection maneuver last year. Launched from Cape Canaveral in September 2016, the 2,110-kilogram OSIRIS-REx spacecraft arrived at Bennu in October 2018. It spent 3 years orbiting the asteroid at altitudes as low as 5 kilometres, mapping its surface, its geology, its composition, its chemical makeup and mineralogy, and of course collecting those samples for return to Earth. This is SpaceTime. Still to come, countdown to NASA's Europa Clipper mission, and crash and burn, a major failure for India's space program. All that and more still to come on SpaceTime. In 1610, Galileo peered through his telescope and spotted 4 bright moons orbiting Jupiter. The discovery of these Galilean moons, as they've been called, Io, Europa, Ganymede and Callisto, dispelled once and for all the long-held notion that all celestial bodies revolved around the Earth. Now, work progresses on the construction of NASA's Europa Clipper mission to the Jovian ice moon Europa, which may also find evidence that fundamentally alters our understanding of the solar system. Europa has a radius of 1,561 kilometres. That means it's similar in size to the Earth's moon. Data from NASA's 1989 Galileo probe studying the Jovian system, as well as the Hubble Space Telescope, suggest that a massive global subsurface liquid water ocean containing 3 times more water than all the Earth's oceans combined exists beneath Europa's thick icy crust. Europa itself has been around for about 4.5 billion years, but its surface is geologically very young, only about 60 million years old. It's incredibly smooth, with very few craters, especially compared to somewhere like the Moon, which is about the same age. And that suggests that Europa's been continuously resurfacing itself, perhaps through a process similar to Earth's shifting plate tectonics. As Europa travels around Jupiter, its elliptical orbit and the planet's strong gravitational pull cause this tiny moon to flex and stretch like a rubber ball, in the process producing a lot of internal heat. And it's that internal heat which is maintaining the subsurface ocean's liquid state. Hydrothermal energy from the moon's core, left over from its formation, could also be heating the ocean at the seafloor. These unique characteristics have led NASA to deem Europa to be the most promising place in our solar system to find present-day environments suitable for some sort of life beyond Earth. You see, there's a growing chorus of astrobiologists now believing that life on Earth may have begun in the hot geothermal vents of Earth's mid-ocean ridges, kilometres below the surface. And Europa Clipper could tell science more about the potential for life on other worlds. Importantly, while Earth and Mars have been swapping rocks for billions of years, thereby leading to the possibility of life on Mars, if it exists there, originating on the Earth, or alternatively, life on Earth possibly having started on Mars, any discovery of life on Europa would most likely have originated there. And if you have 2 places in our solar system where life has started independently, then that suggests life may be common throughout the universe. But of course, for life to exist in the oceans of Europa, there needs to be more than just water and energy. It also needs essential chemicals like hydrogen, carbon and oxygen. And that's where the Europa Clipper mission comes in. It'll try and confirm the existence of these ingredients. The mission's launch from the Cape Canaveral Space Force Base in Florida was originally programmed for an Atlas V rocket, with a flight time of 6 years, using 1 gravity assist from Venus and 2 from the Earth. The mission was later reprogrammed for launch aboard NASA's new Super Heavy Lift rocket, the SLS, on a direct flight lasting just 3 years. However, ongoing delays with the SLS program has forced NASA to instead opt for a SpaceX Falcon Heavy rocket, basically 3 Falcon 9 rockets strapped together. That's now slated for launch in 2024, with Jovian orbit insertion slated for 2030. During its 5.5-year journey to Jupiter, the spacecraft will undertake a flyby of both Mars and the Earth, using the planet's gravity assist to slingshot itself the 780 million kilometres to Jupiter. Arrival in the Jovian system will bring its own hazards, chief of which will be Jupiter's immense radiation belts. So, instead of orbiting Europa directly and soaking up all that harsh radiation, Europa Clipper will undertake a series of highly elongated elliptical orbits, spending as little time in the radiation belts as possible. To further protect the spacecraft, its key electronics will be shielded inside a titanium and aluminum compartment in order to minimize radiation exposure. During its nominal 3.5-year mission, the spacecraft will perform some 45 flybys of Europa, with closest approaches varying in altitude from 2,700 kilometres down to just 25 kilometres above the surface. The 6,000 kilogram spacecraft will carry 10 scientific instrument packages to study Europa's surface, ocean, interior, geology, chemistry and habitability. These include a sub-metre resolution wide and narrow-angle visible spectrum camera, a thermal emission multispectral imaging system to study the surface of Europa in mid to far infrared bands. That'll allow the spacecraft to detect geologically active sites, such as potential vents erupting plumes of water into space. There will be an infrared mapping and imaging spectrometer to study the surface of Europa, mapping surface composition, identifying the distribution of organics such as amino acids, tholins, salts, acid hydrates, water ice phases and other minerals. There'll be an ultraviolet spectrograph to detect small plumes and provide data about the composition and dynamics of the Moon's exosphere. There'll be a dual-frequency ice-penetrating radar designed to characterise Europa's ice crust from near the surface down to the ocean. It'll reveal hidden structures in the frozen world's ice shell and any potential water pockets it contains. There'll be a plasma-magnetic sounding instrument to measure plasma-magnetic fields surrounding Europa. These mask the magnetic induction response of its subsurface ocean, which will be key to determining the ice shell's thickness, ocean depth, and salinity. There's also a mass spectrometer to determine surface composition and that of the subsurface ocean by measuring the tenuous exosphere and any surface minerals ejected into space. And there'll be a surface dust analyzer mass spectrometer. It'll measure the composition of small solid particles ejected from Europa, which will provide the opportunity to directly sample the surface, as well as any plumes to identify traces of organic and inorganic compounds in the ice of ejecta. The ability to study areas where Europa's subsurface ocean could have oozed out onto the surface or erupted in plumes or geysers into space is especially important, as these locations would provide the opportunity to analyse the composition of Europa's subsurface ocean without needing to land or to drill through kilometres of thick ice, potentially contaminating whatever lies underneath. This report from NASA TV.
Europa is the most likely place to find life in our solar system today because we think there's a liquid water ocean beneath its surface. Now we know that on Earth, everywhere that there's water, we find life. So could Europa have the ingredients to support life?
We might be actually looking at a body that is presently alive, presently active, and presently undergoing its geology. There is too much evidence right now lying around on the surface, the red stuff, that suggests that something's going on there. Is that an environment that is habitable for any sort of life form? By golly, we really have got to go back and figure that out.
We have designed the Europa mission to take a spacecraft and its set of instruments all the way from planet Earth to Jupiter.
Previous mission concepts were for a spacecraft that would orbit Europa, but Europa is bathed in radiation from Jupiter. Any mission that goes in the vicinity of Europa is cooked pretty quickly. Instead, we're looking at a mission that will orbit Jupiter, make close flybys of Europa, and then zip out of the high radiation region.
Kind of like when I was a kid, we had the sprinklers, and we didn't want to be too close to the sprinkler head, so we would run in and get a little water and then run back out again.
This allows us to have a mission that's many years long and to collect and transmit lots and lots of data. As Europa orbits Jupiter, it flexes, and we could measure the gravitational change of Europa by encountering Europa at different points in its orbit. On a typical flyby, we would turn on our remote sensing instruments, we would image the surface, we would interrogate the surface with spectroscopy, and we would do the same thing on the way out. And we would essentially rinse and repeat and do this many, many times until we understand Europa globally. Images from the Hubble Space Telescope tells us that Europa might be erupting plumes of water high into space. If that's true, then we could fly through those plumes with a spacecraft and literally taste it to understand the composition of Europa's interior.
If it does have the ability to harbor life, how does that work exactly? We'll have enough instrumentation to really pinpoint exactly how the mechanisms would work for replenishing the nutrients in a subsurface ocean.
Europa is so important because we want to understand, are we alone in the cosmos? If there's life in Europa, it almost certainly was completely independent from the origin of life on Earth. That would mean the origin of life must be pretty easy throughout the galaxy and beyond.
And in that report from NASA TV, we heard from Europa Mission Project scientist Robert Pappalardo, Galileo Mission Project Manager Claudia Alexander, and Europa Mission Payload Manager Sarah Suska. This is SpaceTime. Still to come, crash and burn, a major failure for India's space program. And Virgin Galactic reopens space tourism ticket sales, but they don't come cheap. All that and more still to come on SpaceTime. An Indian GSLV rocket has failed to place a new weather satellite into orbit after an upper stage failed to ignite. The incident happened about 6 minutes after the Indian Space Research Organisation's GSLV F-10 blasted off from the Satish Dhawan Space Centre on the Bay of Bengal coast.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Liftoff normal.
Majestic liftoff and a very good launch of the GSLV F-10.
First stage performance normal.
The steering program of the launch vehicle is designed to enable vertical liftoff until clearing the umbilical tower, which takes about 7 seconds. Then the roll maneuver is implemented to orient the launch vehicle axis along the intended launch azimuth. About 30 seconds into the flight, the gravity turn is initiated. The nominal thrust is 4,815 kilonewtons. The pitch, yaw and roll control is through gimbal of L40 engines.
GSLV F-10 is traveling eastward after liftoff from Shar coast. The 2 TTC stations at Shar will provide real-time telemetry data to Mission Control Center from liftoff minus 30 minutes to 500 seconds after liftoff when geometrical loss of signal occurs.
S139 burnout. L40 is continuing. First stage performance normal.
The L40 strap-ons हैं.
L40 engines shut off. GS2 stage engine started. Second stage performance normal.
The GS2 stage with Earth Storable Liquid Propulsion System is the second stage of the launch vehicle. It is powered with high-thrust Vikas engine, which flew for the first time in GSLV F08 and uses a longer propellant tank from GSLV F11. This stage is loaded with about 42 tons of hypergolic propellants stored in 2 aluminum alloy tanks of 2.8 meter diameter, separated by common bulkhead, and is powered with a turbopump-fed high-thrust Vikas engine. The engine is provided with 2 plain
bearings
for pitch and yaw using electromechanical actuators.
A major flight event has taken place just now, that is the separation of the payload fairing. We are 255 seconds after the launch. The altitude currently is 123 kilometers.
The roll control of GS2 was achieved by hot gas roll control system.
Second stage engine shut off.
The third stage of the flight, the GS3, the cryogenic upper stage, which is the third stage of GSLV, it functions on cryogenic locks and LH2. The stage uses India's first indigenously developed cryogenic engine, CE 7.5, which operates in staged combustion cycle. Thus, has the unique feature of thrust and mixture ratio control systems, which can be fine-tuned based on mission requirements.
Plus 6 minutes.
The stage uses 2 steering engines, is having 2 plane gimballing provision for pitch, yaw and roll control. After continued success, the stage was modified with a length increase to accommodate higher propellant loading for better payload capability. This re-engineered C-15 stage with 15 tons propellant loading has been flown in GSLV F-11 and is flowing in the present mission and planned in future missions as well. This is the 8th time ISRO is flying indigenous cryo stage for GSLV. The nominal thrust of GS3 is 73.97 kilonewtons.
The GSLV, or Geosynchronous Satellite Launch Vehicle's first and second stages, performed nominally, but the third and final stage failed to ignite.
Cryogenic engine से
The launch of GSLV F-10 has taken place today, and the outcome of the mission will be announced by ISRO soon. Right now in the Mission Control Center, senior scientists are in discussion regarding the performance of the flight.
Attention all stations. This is Range Operations Director. Performance anomaly observed in the cryogenic stage. Mission could not be accomplished fully.
The mission was carrying the new EOS-03 weather satellite, which was designed to provide real-time images to monitor cyclones and other natural disasters. The satellite, which was to be placed into geostationary orbit, was carrying enough fuel for a 10-year lifespan. The 49-metre tall GSLV is designed to carry up to 5 tonnes into low Earth orbit and 2.7 tonnes into geostationary transfer orbit. It was the fourth failure of a GSLV launch vehicle in 14 missions. India's last launch failure was in 2017, but that involved the smaller 4-stage PSLV, Polar Satellite Launch Vehicle. The 44-metre tall PSLV is designed to carry 3.8 tonnes into low Earth orbit and 1.3 tonnes into geostationary transfer orbits. This is SpaceTime. Still to come, Virgin Galactic reopened space tourism ticket sales, and later in the science report, a new study claims that COVID-19 may have knocked up to 9 years off average lifespans. All that and more still to come on SpaceTime. Virgin Galactic has reopened ticket sales for space tourism flights aboard its winged rocket plane. But the price has skyrocketed from the original $250,000 a seat up to a new starting price of around $500,000 a ticket. The company expects to start revenue flights from its New Mexico spaceport next year. The move follows a surge in consumer interest following last month's successful test flight to an altitude of 86 kilometres, which included the company's boss, Richard Branson. Virgin Galactic's also planning a research flight for the Italian Air Force next month, and that will include Italian payload specialists conducting experiments during apogee. The payloads will include medical instrumentation measuring the biological effects of transitional phase from gravity to microgravity on the human body, and a study looking at the chemistry of green fuels under space conditions. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study shows that glaciers and ice caps in 2 archipelagos in the Russian Arctic are now losing enough meltwater to fill nearly 5 million Olympic-sized swimming pools every year. The findings, reported in the Journal of Geophysical Research, are based on satellite data collected by the European Space Agency's Cryosat-2 spacecraft. Scientists found the amount of ice lost between 2010 and 2018 would put an area the size of the Netherlands under 2 metres of water. Researchers found that warming of the Arctic Ocean appears to play a key role in accelerating ice loss from 2 large groups of islands that border the Kara Sea. Scientists from the University of Edinburgh found the archipelagos, which cover a combined area of 80,000 square kilometres, lost 11.4 billion tonnes of ice every year between 2010 and 2018. A new study has concluded that COVID-19 may have knocked up to 9 years off an average lifespan. The findings, reported in the journal PLOS ONE, are based on a new method that looks at the effects of temporary shocks, such as the coronavirus, on average lifespans. Researchers call the new metric Mean Unfulfilled Lifespan, or MUL, which is the difference between the average age of death for those who've died in a given time frame and the average age these individuals would have been expected to reach had there not been a temporary shock to mortality rates. The authors show how MUL can be used to compare the impact of COVID-19 between different regions. Calculations suggest that lifespans were cut by 8.91 years in New Jersey, 8.96 years in Mexico City, and 12.7 years in parts of Ecuador. The World Health Organization estimates that more than 8 million people have been killed by the COVID-19 coronavirus, with over 4.4 million confirmed fatalities and more than 205 million people infected since the deadly disease was first spread from Wuhan in China. A new study warns that HIV pre-exposure prophylaxis, or PrEP, may be changing the way people think about safe sex. A report in the journal PLOS ONE found condom use is becoming less of a focus among gay men because of increased reliance on PrEP medication. PrEP is an HIV prevention method in which people who don't have HIV take the AIDS medication emtricitabine in combination with tenofovir to reduce their risk of getting HIV if they're exposed to the virus. Researchers interviewed gay men and conducted focus groups with doctors involved in PrEP prescribing, as well as staff working with HIV and LGBTIQ community organisations. They found that nearly all the men reported that increased access to PrEP meant they tended to use condoms less for casual sex. The study also found there was evidence of potentially damaging new norm emerging where PrEP use was seen as the best form of AIDS prevention for HIV-negative men, and those who didn't use it were stigmatised. A new study has suggested that fecal microbiota transplantation from young people to old people could counter ageing-related changes in the brain. The findings, reported in the journal Nature, haven't involved human trials yet, but early studies have found that the transplants reversed age-related changes in the immune system. Researchers also found that recipients improved in several cognitive tests for learning, memory, and anxiety. Well, if you think your smartphone's spying on you, you're probably right. Apps are already tracking your location and online browsing habits, and some even turn on your phone's cameras, its microphone to pick up conversations, and they can read your notes and messaging. Last year, Apple introduced a new feature showing an orange dot on top of your phone when your microphone's activated and a green dot when it's your camera. But it now looks like Apple's crusade to protect your privacy is over. The Big A have announced plans to start scanning iPhones for illegal content and reporting what they find to law enforcement. The tool, called Neutral Hash, will initially be scanning for images of child abuse, a move strongly supported by child protection groups who describe it as a game changer. It works by comparing pictures on an Apple device to a database of known child abuse images, which are translated into numerical codes called hashes. Tech companies, including Microsoft, Google, Facebook and others, have for years been sharing digital fingerprints of child sexual abuse images, and Apple's used those to scan user files stored on its iCloud server for child pornography. But the move has raised concerns among privacy and online security groups because it could be used by authoritarian governments to spy on citizens, monitor their behaviour and undertake surveillance of dissidents or protesters. Privacy groups say Apple's actions signal that it's now safe to build technology that can scan your phone for whatever's deemed prohibited content or even political speech. And if you think it's a once-off, think again. Local concerns have been raised following revelations that despite assurances by governments across Australia that QR code safety check-in data would only ever be used for COVID contact tracing, police quickly began accessing the data to trace people's movements. Technology editor Alex Zaharov-Royd from IT Wire says new versions of iOS and iPadOS, due to be released later this year, will have the new cryptography applications included.
Look, it is true to say that Apple should have been a bit more upfront about this and could have tried to introduce this in a better way, because it certainly has caused a lot of concern. But one of the questions I ask is, could governments force Apple to add non-CSAM, which is the child sexual abuse material images, to the hash list, the list of photos that have been determined to be illegal? And Apple says it will refuse any such demands. Apple's CSAM detection capability is built solely to detect known CSAM images stored in iCloud photos that have been identified by experts at NCMEC, NCMEC, and other child safety groups. So, I mean, they go into a lot of details. They say, can non-CSAM images be injected into the system to flag accounts for things other than CSAM? And Apple says our process is designed to prevent that from happening. The set of image hashes used for matching are from known existing images of CSAM that have been acquired and validated by child safety organizations. Facebook reported 20 million instances of CSAM to the NCMEC organization last year, and Google reported 546,000 of those. So this could be quite a job for Apple, seeing as it does have over 1 billion iOS users. But hopefully this will make people who engage in this sort of information think twice, because they won't be able to hide behind encryption anymore. And I mean, we have had people like WhatsApp saying, we're never going to be scanning people's images, but that's coming from a company that's owned by Facebook. It's well known to be playing fast and loose with privacy and going on apology tours. Hopefully out of all of this, children will end up being protected.
Nobody has a problem with stamping out child sexual abuse. And if they move it a step further to controlling things like terrorism, no one has a problem with that either. No reasonable person anyway. But what's to stop governments from pushing that even further? And that's the real fear. We recently had a situation where everyone's QR codes were supposed to be only for contact tracing for COVID-19. Yet we know police immediately, first thing they did when this became available was to start using people's QR codes to find out where they've been. The fact is, once you pry the door open, it never closes again. It just gets wider.
Sure, it's Pandora's box. I mean, Ronald Reagan famously said that liberty and freedom is not passed down through the bloodstream, but must be fought for by every generation. And, Apple's are saying that they will refuse any such demands. They have form in having refused the FBI. If a government is going to put the screws on Apple to get them to force this information out of them, I mean, we just have to hope that Apple is strong enough to stand against it. In Australia, we have the government trying to get companies to break the encryption and to allow them to scan messages for terrorist activity. So could the government ask for political dissidents to be identified?
It's not a question of asking. It's a question of if you're in Belarus, for example, they're not going to ask. They're just going to order it. It's that simple.
Yeah. Well, this is where we need the US to remain the beacon of freedom and liberty.
That's Alex Zaharov-Reutt from ITY.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.